Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatan min lisani yafqahu qawli. In the name of Allah, the most beneficent and most merciful. Uh, Today, I will start with a new course that is Engineering Surveying, and this is Spring 2023. The course is the first level course that being taught in Department of Urban and Infrastructure Engineering. And the topic of our discussion is obviously surveying fundamentals. This is the course outline we are going to follow, and we'll have this schedule right from March 6 to July 17, 2023. The course textbook is The Elementary Surveying by Charles D. Gilani, Paul R. Wolf. It's the 14th edition, and the publisher is Prentice Hall, and it was published in 2014. The reference book are Surveying by Francis H. Moffett or H. D. Boshart, Surveying with Construction Applications by Barry F. Kavanagh, the latest edition. What are the course learning objectives? A student will be able to explain the basic surveying techniques used for surveying and leveling. This is a cognitive level 2 course, cognitive learning level 2, and it's tied with the PLO, engineering knowledge. The second learning outcome or learning objective of this course is the student will be able to prepare maps and plans, the contour maps, the profiles, cross-section, etc., using surveying technique that has been taught in this course. This is a cognitive level 3, and this is related to the problem analysis. The last but not least is this is psychomotor level course, 3, psychomotor 3, and students will be prepared and will be able to operate various survey equipment like theodolite, totalization, and maybe TNS, and it comes under modern tool usage of the program learning outcomes. Now we start with the CLO1, explain basic surveying techniques used for surveying and leveling. So what is surveying? What is surveying? It's an art and it's a science of taking field measurements on or near the surface of the earth. What does it include? It includes measurement of horizontal and slope distance, the vertical distance, horizontal and vertical angles and position. Now, when we talk about surveying, it's not about measurement. Yes, it's about measurement of an existing structure, and it's about measurement for a proposed structure. That is what we call a layout. So surveying, by use in surveying, we not only measure the existing structure, but for the proposed structure, for a future structure, we do measurements so that the whatever we have constructed is according to the scales set forth in the drawing. And obviously, we need surveying instrument to lay it out. So the common terminology maybe is the layout of the project. So surveying can be defined in this manner, that it's take measurement for the existing structure, as well as we use surveying to lay out the proposed structure as well. Now, sometimes nowadays, the two terms, geomatics and surveying, seems to be, seems to be a synonym of each other, because geomatics is the term describing the computerization and digitization of data collection, data processing, its analysis, and data output. So whatever we do in surveying, we put it nowadays into digitized form. So that digitization, and obviously when we digitize the data, we do it, we process it, we analyze it, and have another output of the data, and that's we call a geomatics. You see, if you're a very first level student, geo means earth, matics always means method. It's a measurement. It can be a science. It can be a knowledge. So geomatics, studying the earth, and obviously in surveying, when we study earth in terms of in reference to the measurements. What is engineering surveying? It includes those activities involved in the planning and execution of surveys for the location, design, construction, maintenance, and operation of civil and other engineering projects. Most of the people, most of the new students think that surveying is limited to the civil engineering, or a surveyor must be a civil engineer background. It's not like this. Surveying, I feel, it comes in every aspect of any professional. Just like if you are a mechanical engineer and there is a machine, if you don't know surveying, how would you install the machine? How will you take the measurement? How will you help the civil engineer to install that machine? So if you don't know about surveying. Similarly, the telecommunication engineering, we have to lay out towers. We have to lay out the mobile transmission towers. And if someone is not familiar with surveying, he may not supervise that project. And it says the same with the electrical engineer as well. So surveying is also a field that's not limited to civil engineering. It also is also applicable in other trades of surveying, or in the trades of engineering. So what activities we included? Preparation of surveying and related mapping specification, execution of remote sensing and field surveys for the collection of required data, including topographic and hydrographic data. Calculation, deduction, and plotting for use in engineering design provision of horizontal vertical control network, provision of line and grade for construction. Again, the measurement of materials and other quantities for cost inventory, cost accounting, and payment purpose, and the execution of as-built surveys and plans are also part of engineering survey. People are always refer either the plane surveying or geodetic surveying. The differentiation between them is very easy. Is that if you are not going to consider the curvature of the earth, then it's a plane surveying. And if you consider the curvature of the earth, we got geodetic survey. This earth is an ellipsoid or shape for order. It's about the purpose of the work. Sometimes we need to have a geodetic survey, just like for aerial photographs or something. But for a small scale, say for instance, if I have to lay out a building of around 1,000 square meters, so I may not need the curvature of the ground. But if I'm talking about building a coastal harbor, if we're talking about the airport and all those things, a larger project, then we cannot ignore the curvature of that. So depending upon the purpose of the survey, we can perform plane surveying, and we need to perform geodetic survey, or we need to take the curvature into the account while measuring it. Now, What are the two most common applications of surveying? The location of the ground features to prepare a plan or map of the area. The design features shown on engineering plan, located in the field by distance and angle measurements or through positioning technique. There are 5 phases in surveying work, or the surveyor has to do making the decision. He needs to understand the method, he needs to select the method, decide upon the method, the equipment he or she is going to use, and define the qualification. This is the decision becomes very important. Sometimes you may need a total decision, or the times the survey was only a level machine, the automatic level is served. And sometimes both of uh, both of them will not work, and we have to use either the drone survey, or we need to use global navigation satellite system or GPS system for that accurate survey. Then once the second thing, after knowing making the decision about the instrument, about the method, there is a field work and data collection, and that's why whatever measurement has been taken, and it's recorded in the field. And once those recorded data is with the surveyor, he will pass on for data processing. That includes calculation based upon the recorded data to define equations in a usable form. So once you have the data process, obviously the next step is to map or represent the data. Mapping means plotting data to produce something with a scale. It can be a plan, or it can be a bar chart in the proper form. And last but not least is to take out, indicate and establish the monuments or the proper locations in the field. So these are the 5 phases or the 5 areas of the surveyor, and they are in that order as well. It cannot be 5, cannot come one before one, or it's not just a writing error or a lecture error. It's a lecture sequence. The sequence always follows. Select method, take measurements, do calculations, do mapping, and last but not least, to lay out whatever has been, whatever you have collected. Briefly, because this is the introduction lecture, we'll talk about type of surveys. 7 types can be identified. One is photogrammetry, obtained by camera, other sensor, guided terrains, satellites. Now we have the drones replacing the airplanes. We need laser scanning or remote sensing. So this is survey done from what we call an aerial survey as well, from the level of the ground. Then the boundary survey, establish property corners, boundaries, and areas of the land parcel. It can also be done using photogrammetry, but generally you can use photogrammetry for other specified works. Then the control survey, establish a network of horizontal, vertical monuments that serve as a reference for other survey projects. Then we call engineering surveys. Basically, it's a layout of a civil engineering project. We provide points and elevation for the building or any infrastructure that is to be constructed. There is a topographic survey in which we collect it and prepare a map showing the location of natural and man-made features and elevation of point to the ground for multiple buildings. Route surveys. This is topographic and other surveys for long, narrow projects, civil engineering projects, such as highways, railroads, pipelines, and transmission lines. In the hydrographic survey, mapping the bottom of the oceans and waterways, also known as the bathymetric survey. So, by now, let's summarize what are the uses of surveying. Establish control for use in the surveys. Map the surface of the earth, map archaeological artifacts, map the bottom of oceans, create geographic and land information system, perform ordnance survey for the military, create topographic map, optical tooling, mapping of statues and other form of artwork, mapping of accident sites in a forensic survey. Now, for surveys are also made for underground utilities, and why we need that survey is to provide an accurate report of the location, so that these utilities can be found if repairs and servicing is needed, and to prevent the accident destruction during execution of other projects. For example, if you have not got the data of the utilities that is buried in the ground, and you and want to have another project, so that if you applied some heavy machinery and you don't know where, for instance, the electrical cable is, that it will cause in the catastrophe that for that project before it will damage service. Why we need topographic surveys? Create maps for highway design, create maps for construction surveys, for floodplain, for site location of buildings, dams, garages, stormwater drains. And so why a hydrographic survey? Shown lines define boundaries of the water, oceans, streams, and other bodies of water. We say sea service is associated with port and offshore industries, and the marine environment include measurements and marine investigation maintained by seaports. Now, what activity you can do is to have view of your house location using Google, and you can produce the image of your. This is a simple homework how to use Google Earth. Google Earth nowadays is a very good hands-on for surveying. Now let's see what is the history of the surveying. Began in 1400 BC. Land along the Nile River was divided for taxation. Division was washed away by annual flow. The first thing they have done is use rope stretches. The space surveys were created to relocate the land. Measurements were made with ropes having knots at unit distance. Extension use of surveying was found in building of Egyptian monuments. Studying any science without the Greek mention is something very strange. So Greeks were also there in surveying. So whatever the work Egyptian has done, Greeks have extended their work and developed geometry. Developed one of the earliest surveying instruments was called a diopter. It's a arm of level, as you can see here. So here, this is the eyesight. You can see this thing. This can be used for the alignment, and this can, if all of them are balanced, then this line is vertical, what can be used as a survey. Then comes the Romans. They developed surveying into science to create the Roman roads and aqueducts and land division service. Had get powers, had schools and professional organizations. This developed such instruments like Groma cross instrument used to determine lines at right angles, Libella air frame, the plumb bob used for leveling, or about 720 feet straight edge with oil in notch for leveling. Middle Ages, there is the land division of Roman continued in Europe. Instrument were quadrants, square brass frame capable of turning angles up to 90 degrees, and had a graduate scale developed by an Italian named 1 piso. after 20th century and beyond, the technology advanced, so is the surveying, and we have a land value cost development of licensure for surveys in all the countries, and that surveying in all surveying departments are there, like Survey of Pakistan, Survey of any other country. Educational requirement for license began in 1990s. Now the surveyors were awarded license to do this job. They were trained to specially to perform the job adequately. It is now complete science. It's an education science. There are universities, they offer a degree for surveying as well. Then is capable of electronic distance measurement, position using global position system, construction machine control, and LiDAR scanning mapping. It's involved in rebuilding of the infrastructure in geographic information system, and shortage of licensed professionals is projected well into the future. Still, there are people who are doing this job without license. Then comes the aerial photographs and satellite images. There's many applications surveying in land surveying to compute coordinates of section corners, boundary corners, or point of evidence that help locate these courses, large-scale maps made by photographic procedures for many uses. Photogrammetry is used to map shorelines in hydrographic surveying to determine precise ground coordinates, develop maps and cross sections. Photogrammetry play important role in developing the necessary data for modern land and geographic information system. Then there is another terminologies, very common terminologies where we have professionals. We need these professionals nowadays, and this is developed, in late 21st century, the start of the 20th century, 2000s, and the GIS overlay soil type and their cumulative slopes. GIS can also provide a list of business and intelligence that will be affected by possible flooding. It can provide best routes out of a flooded region, etc. Now, the classes of survey: preliminary survey, in which we have a rectangular tines, we have polar tines. One is a rectangular coordinate. What rectangular coordinate we know is the coordinates in terms of x, y. Polar, we have one distance and the other angle. We call this especially r theta if you have a knowledge of mathematics. Then we have a intersection ties in which we know these intersection of the coordinates. We have to position the tines. Then the layout survey: rectangular layout, polar layout, positioning layout, machine guidance. Then there is a control survey like this. You have to locate a point perpendicular from line AB, and from C you can stretch this particular. So this can be done using a rectangular coordinate system, or this can be done by what we called polar coordinate system. And the third one is positioning, in which we locate the point in such a manner that P is the end point of A and B can be sighted through point P. This is what we call a positioning system, in which you position your point with respect to A and B. This is a trial and error method. Here we can position the point P by using a polar coordinate. We know how much, at what angle P is from A, and how much P the distance, what we call R, and this is a P having coordinates, known coordinates of B and A, and obviously by electric it from C. Then comes another terminology that we call stationings. Our dimensions measured along a baseline. Beginning point is always 0 plus 00 if you are using a fleet ground system, or it can be 0 plus 000 if you're talking about a metric system. A point 100 feet means it's 1 plus 00. Now, of the 2 digits means you're talking about measuring entrants. Can be 3 digits, then it can be as measured. It can be in metric system. 565, 9.98 can be now how we can do it. We have 500, so we write 5 separately, and 65.98. So simply if you divide this by 100, you will get 565. So you write 5 separately plus. So always if this is not known to you, this is 500. If you just remove this plus, then this is 565.98. Now some highway agencies use the metric system. That's obviously 1000 meter instead of 100 meter. So this can be 0 plus 0, 0. 1 kilometer is represented 1000 meter. Obviously, 1 is, if you need to know what is this distance, if you remove plus, then this is 1000 meter. Or if it is 1000 meter, versus if it is 1565. So it can be written as 1 plus 565. Or if it is 1 plus 565, it is actually, you remove plus from it and you will get the actual. Points were measures are 0 plus 0, are 0, 50, minus 1, plus 100, etc. as well. So this is, for instance, we started the first point. For example, there is a school building located along this road. So if you want to have the referencing, what we do, we start at the middle of the road and we start measuring, and we need to see how much this school, first corner of this school is from the center of the road. So we go along the baseline. This is my baseline, or we can say like this. This is the perpendicular line along the center line of the road. Now along this perpendicular line with reference to the center line of the road, and we start measuring from this point, and this corner, we have cited this corner, we found that this is 217.36. So what we have done, we have located this point, and then the second point, the next corner of this school building is 315.34. So we write 3 plus 15.24, and this means this corner of the building is 315.34 feet from the center line of the road, and this corner is 217.36 feet from. Now, since the building is not parallel to this road, parallel to this line, so we need to take this measure and best way. How far at this point, this corner is from the, let's say, center line of my reference line. So it is 60.21 and by 40.2. Now I can easily, know how this school is oriented. And once I know this point, I can always lay out this 100 by 60 building in this manner. So this ends my first lecture. I hope you understood it and studied it very well. So I will have soon recording of lecture 2. Till then, Allah Hafiz.